It's a chessboard. Castle to E4!
Hello everyone out there. My name is Ross. I'm one of your TAs this summer. And I'd like to introduce you to Checkers61BL, which is the first project that you guys will be working on this summer. It's an individual project, so no partnerships this time. And in this video, my goal is to talk a little bit about the structure of the Java code you'll be working with, and also the rules of the game and how you play. So this project has two parts to it, really. You have to build the logic for the board itself. First, you have to build the logic for the individual pieces, and then you have to build the whole logic for the board and how the pieces interact and move around the board and whose turn it is, things like that. And in addition, you also will be building this graphical interface that you see here so that you can play it like a real checkers game by clicking on the pieces and moving them. So let's get started. So once you've downloaded the starter code and you've opened it up in Eclipse, you will be greeted with these files here, some of which are named board and some of which are named piece. I'm going to start talking a little bit about the piece class. So the piece class is basically a representation for what a piece is in your checkers game. A piece knows a few things about itself, like which side it's on, which player it belongs to, whether or not it is a king, and we will talk about that later. And then it has some other methods that allow it to do some other things to other pieces. There are three types of pieces. There's the normal piece, which is this class here. And then we also have the bomb piece and the shield piece. And both of these piece classes inherit from the main piece class and just change a few things. Next, we have the board class. And the board class deals with essentially the underlying representation of the checkers board, where the pieces are on the board, things like whose turn it is, things like that. So, and it has all these methods that allow you to interact with the board, move and select pieces around, and also see who the winner of the game is. And this main method here, which actually starts a game. So your board class is really going to be in control of what's going on in the games, and it sort of stores the pieces on it and where they go. So we have provided you this DemoBoard.java class here, written by Daniel. Thank you, Daniel. That sort of gives you an example of how you would build a representation of a board, both in the logic of the pieces themselves and also what the graphic interface looks like. So why don't we just go ahead and run this file and see what happens. Okay, so this is our demo board here. It looks like a 3x3 grid, colored gray and cyan. And let's see what happens when I click. Okay, so I can put X's. I can hit spacebar to change whose turn it is. And it looks like I can play a little game of tic-tac-toe here. Cool. And as I click on the squares, a piece is put into that square. So the GUI knows where my mouse is when I'm clicking. It's also responding to the keyboard when I hit it. That's pretty cool. So let's actually talk a bit about how this demo works and how you can use it to turn it into a real checkers board that you can use in your project. So let's go down to the main method where things are actually happening here. So what's the first thing that happens? We create a new demo board and we pass in a value 3. So let's go check out the demo board constructor and see what's happening. So here's our constructor, and what does it do with that integer it takes in? Well, it sets this pieces variable, and it creates a new integer array. Looks like a 2-dimensional array. So we have one for rows and one for columns here, and it uses n for both of them. So it will turn this into a 3x3 board. And as we see up here, the description for our int array of pieces is that 0 represents an x, 1 represents an O, and -1 is an empty space. So what's happening in our constructor? We have these 2 for loops here, one that will go through all of the rows and one that will go through all of the columns. And all it does is set every value in the array to -1. And -1 represents an empty space. So all this does is start us out with an empty board that we can then add pieces to, as you saw before. So let's check out what happens next. So now we call standard draw plus dot set scale. So what is standard draw plus? Now standard draw plus is a graphical library that we've provided to you from Princeton. You can look at the file here. It's long and complicated. It has a lot of crazy functions, but there's only a few things you really need to know how to work with it. So it's not too difficult to get the hang of. The first thing we do is set a scale for the board. So this is sort of setting, I guess, a size of the board that we'll be working with. And notice here that we created a demo board that is a 3x3, and our scale also goes from 0 to 3. So maybe the scale of the board and the size of our actual array might work together to create a proper board. Let's see what happens if we make the scale larger. Let's set the scale to, say, 6. And let me close our last one and open up a new one. Okay, so when we upped our scale, our board is now a lot smaller compared to the entire space we have. And that's because our board is only a 3x3, but our scale essentially allows for a 6x6. So we are only using up one small part of our entire board, and there's all this unused space. And what we want is an 8x8 board. So maybe if I change these both to 8, see what happens. Yeah, okay, so that is looking more like a chessboard. Awesome. After we have done that, we have this while loop here that is running as long as true. Well, that means this while loop will run infinitely until we stop it. And essentially this while loop will be constantly running throughout the game. And what it will do is it will draw the board, and it will watch to see if we ever press the mouse. And if we do, we can get the coordinates of our mouse and do things with it, like place a new piece maybe. And it will also watch if we press the space bar, and it will use that to switch our side. So let's check out this draw board call first. So where is draw board? Here it is. Okay. So in draw board, it looks like we have another set of 2 for loops. One that goes up to pieces.length, which is the outer array essentially in our 2-dimensional board that deals with either the rows or the columns. Let's say it deals with the columns. So I goes through the columns, and then for each column, our J will go through each row. Because if you access one of the indices of the outer array, then you will get another array, which is the other dimension, essentially, of our two-dimensional array. So these for loops are going to go through every square in every row and column, and it looks like what it's doing here is setting a pen color to either gray or cyan, which you saw before were the colors of the board, and then it creates a square, essentially, and it does I plus 0.5 and j plus 0.5, and we'll see what these 0.5s mean in a sec. But these pen colors, essentially, this call to set pen color is going to change what color any of your future calls to standard draw plus will use. So this filled square will use whichever color we set it to last. And this if statement here is just sort of a nifty thing that will alternate the board between our two colors and make it look like a proper chessboard. So let's actually see what this filled square call is doing, and I'm going to roll over it. And it says it takes in three things. It takes in the x coordinate of the center of the square, the y coordinate of the center of the square, and the radius of the square, which is the distance from the middle of a square to the center. Well, what does that all mean? So in our main method, you'll remember we set a scale of 8 from 0 to 8, and we have a board which is an 8 by 8 board. So let me go ahead and open up our board again. You can see it looks like this. I can still put pieces on it just like before. And since we set our scale from 0 to 8 and we have an 8 by 8, essentially what that means is that every square on this board is a 1 by 1 unit in our GUI, basically, because there are 8 squares here, and since our scale goes up to 8, each square takes up 1, so that overall they take up 8 units. So each square is 1 unit, essentially. And in our call to filled square, these numbers are inputted in the units of our board, basically. So when we say I plus 0.5, let's say that we start at I is 0 and j is 0. So we will start down in this corner of the board here. This is where 0, 0 is on our GUI. So right here, we are going to go ahead and say, let's draw a square at I plus 0.5. So that'll take us to 0 plus 0.5, and we'll end up right here. Next, we will move j plus 0.5. So we will move up 0.5 to here, 0.5 of a unit, and we'll end up in the center of the square. And finally, we'll use the radius of a square, which is 0.5, which is the distance from this center out to the edge of that square. And so that call will create this perfect little gray box here. And our for loop will go ahead, our two for loops here will go ahead and do that for the entire board. And we end up with this nice checkerboard, as you see here. So after it draws, or once it draws a square, it will then use those I and j coordinates, and it will look in our pieces array, and it will see whether or not we have a piece at that square. And if we do, then it will make this picture call. And a picture call just takes in the location of an image, and then takes in a center, just like our filled square call, as well as a width and a height, and then it will draw it on the board. So let me do an example. Let's try changing one of our pictures, maybe. We have this image folder here, and let's go ahead and add a water pond. So I will change this call here to image/pond, water.png. And now in our board, let's see what happens when we click. Aha! So now it places water ponds. And my recording software just cut me off for going over the limit. But now we're back, and in the meantime, I changed the sizes on the ponds to be 3 times as big. So that is how you add pictures to your board. Now, the last thing I want to cover are these 2 calls, this one to mouse pressed and this one to is space pressed. So this is how your GUI is going to interact and be able to respond to your mouse and keyboard inputs. So if the mouse is currently being held down, then mouse pressed will return true. And remember that this while loop is constantly running, even if nothing is currently happening on your board. So it's constantly waiting for an input from either your mouse or your spacebar. So when the mouse is pressed, we make these calls to mouse X and mouse Y, and these give us the coordinates of our mouse on our GUI. But these coordinates that we get from this call are decimal numbers, and all we want are the plain integer coordinates that represent them so that we can access those squares in our pieces array and then actually be able to put a piece there and have it drawn in our next call to DrawBoard. So what we do is we use a typecast here to an integer. So we tell the Java compiler, I would like to treat the output of this function as an integer. And the result of that is basically it chops off whatever the decimal part of it is and just leaves us with the actual integer part. So I'm actually going to go ahead and print out these values just to show you how this works. So now let's open up our board here and watch what happens when I click on this bottom square here. So 0, 0 showed up. So that tells us that the coordinates of this square in our pieces array is 0, 0. How about this one in the bottom right corner? Okay, so that is 7, 0. And you notice this printed 5 times. That's because your computer is running that while loop very, very quickly. And as long as your mouse is held down when it reaches this call, then it will register as a click and it will go into this and record the inputs. And now we're printing them. So if I hold the mouse down, it's just going to infinitely print 7, 0. The takeaway from this that you should get familiar with is that this is the square 7, 0, whereas this one up here is 0, 7. So what do you think this square is right here? Well, the first number is counting from left to right, so we start at 0, 1, 2, 3. And then the second number, we start at 0, 1, so this should be 3, 1. Yep, so this is the square 3, 1. And lastly, this call to is space pressed will return true whenever your spacebar is held down, and it will change the current side. This is sort of a little trick where if you use side only being 0 and 1, then when side is currently 0, this will become 1 because 1 minus 0 is 0. But if your side is 1, then your side will become 0 because 1 minus 1 is 0. So it basically flips back and forth between 0 and 1 whenever you press the spacebar. Let me show you that working. Oops. Hang on. Ooh, it wants to make my webcam all huge. Why is that? Okay, well I can't type the letter D or it messes it up. Cool. So then we will leave it as space press, like a French term, I guess. So in our board, when we press space, you'll see that the space is in fact press. And if I hold the spacebar down, it's just going to do that a bunch of times. So really, you're not sure which side you're going to end up on because you're rapidly flipping back and forth. And that's actually something you will want to account for in your board because you don't want to be able to keep flipping back and forth between a side. You only want to change to the opposite side once and then stay there until that side has made a move. And there are other rules of the game, like you can't make more than one move on your turn, and other things like that. Logic that will be needed to keep track of inside your board. So that is an introduction to the GUI in this project. Next in this video, I'll be talking about the rules of the game and the pieces and how they work. So thanks for watching. Stay tuned. Okay, so we are now in the part of the video where I will start talking about the pieces in our game, how they move, how they capture, and how you win the game. So let's go ahead and start with the normal piece. So in the spec here, it says that the normal piece moves diagonally and captures diagonally. So this is pretty much your standard checkers piece. If you played checkers before, it will be very familiar. Except for some reason in our game, it has a picture of a chess pawn. That was not my idea. So once you've messed around with your GUI a bit, you should get a board that looks like this, where you have some red squares and some gray squares. And now I'll go ahead and show you how the normal piece works. So here we have a little demo board between our two teams, fire, which moves upward, like it's rising up in flames, and water, which moves downward, like it's falling down, like rain. So I'm going to go ahead and move one of these fire normal pieces. So what happens when I click on one is that square gets highlighted, and that's the game showing me, okay, I've selected this piece, and now I can decide to move it if I want to. Or maybe I wanted to choose a different piece to move instead, so I can click on this one maybe, or this one. But I think I'm going to go ahead and move this one here. So after I've selected it, now I get to choose a square to move it to. And since my piece can move diagonally, then I can either move it to this square or this square. And I'm going to go ahead and move it here. And once I've done that, I hit spacebar to end my turn, so space. And now you see the square is no longer highlighted, and it is now water's turn to move. So I'm going to go ahead and select this piece, and let's move it here, and end my turn. Now, that was actually a very bad move for water, because now fire can go ahead and capture that piece. So I'm going to select this piece and capture this one. And in order to capture a piece, all you do is, just like in checkers, you move to a square on the same diagonal as that piece, but that is the square right past it. So I'm going to click on this square here and see that my pawn, or my normal piece, moved here, and the water piece disappeared, which means I captured it. And now I'm going to end my turn. So over on water here, I can select this piece, and I would like to capture this fire piece here. But in order to do that, I have to be able to jump to a space where there is no other piece. But unfortunately, there is a fire piece here already. So this is essentially blocking me from capturing it. I cannot move here. I can try and click on it, but nothing happens. So I guess I have to move here instead. And that is how the normal piece works. Okay, next, let's talk about the bomb piece, because that sounds exciting. A bomb piece is a lot like a normal piece in this game. It moves diagonally and it captures diagonally, except the difference is after you capture a piece with a bomb, where it lands, it will trigger an explosion that detonates all the pieces in the vicinity. So let's check that out. So here we have a setup where we have a blue water bomb that is ready to explode into a bunch of these fire pieces. So I'm going to go ahead and start off as fire and move here, which is an incredibly poor move and allows water to do some serious damage to fire's pieces here. So as this bomb, I'm going to go ahead and capture this normal piece. So I'm going to click here, and once I land here, I'm going to trigger an explosion that detonates all the pieces in a 3x3 block. So everything in this little box here is going to get blown to smithereens. And bombs don't care what team a piece is on. So whether it's a fire piece or a water piece, it will get blown up. But this piece here is outside of the range, so it will stay safe. So let's watch what happens. Boom! So we destroyed this piece by capturing it, and all the rest of these were blown away in the explosion. But this little fire piece remained. So let me explain a little bit more about bombs. I need to end my turn first. So in this example up here, I will show that bombs do not trigger a chain reaction. So when I jump to capture this piece and I jump here, this bomb will get blown up by the explosion, but it will not cause another explosion. So this fire piece will not be destroyed. See? And that's how the bomb piece works. Okay, so the last piece I need to introduce is the shield piece. And as you'll see here, they have a picture of a shield with some pretty rad looking flames here and some water droplets. Let me tell you how they work. So shield pieces are, again, like a normal piece. They can move diagonally and they capture diagonally. So I'm going to go ahead and select this piece and move it here and end my turn. Now, as water, I could decide to take this shield piece and capture this shield piece if I wanted to. I can totally capture normally if I want. But actually, I'm going to decide to capture it with this bomb piece instead to show you why shields are useful. So if I were to use this bomb to capture this shield, it will work normally. This shield will disappear and the bomb will capture it. The difference is, and the cool thing about shields, is when your bomb explodes and a shield is in range of that explosion, it will actually not be destroyed. So watch what happens when I capture the shield here. And I click here. Aha, so the fire piece disappeared because it was blown up in the explosion, but the shield piece stayed. It was not blown up. And that is the cool thing about shields, and that's the last piece in the game. Now I'll go ahead and talk about the two special rules of our checkers game, which are multi-capturing and crowning. Now, both of these carry over from the real checkers board game. So if you are familiar with checkers, you should be familiar with these as well. Now, I am fire, so I am going to take this shield piece and I'm going to go ahead and capture this water piece by jumping here. Now, as before, I have the option of ending my turn. However, I also have the option of making another capture on this water piece here. And this is called multi-capturing. So I am not allowed to make any other moves in this state. If I want to move here and click here, I can't. However, I am allowed to capture this water piece and jump here, like so. So if you have captured a piece on a turn and you are able to capture another piece, then you have the option of doing so. So I have just performed a multi-capture. So I'm going to go ahead and end my turn. And now water can go ahead and capture me. So that is multi-capturing in checkers. Now I'm going to go ahead and talk about the second rule, which is called crowning. So as you know, your pieces start at the bottom of the board here, and the fire pieces start at the bottom here, and they march upward towards the top, where the water pieces are moving down towards the bottom. And what happens when you get to the top or the bottom row, you might ask? Well, let's find out. So I am this fire piece, and I'm going to capture this water piece and jump here and end my turn. Now you'll notice that this yellow crown here has appeared on top of that fire piece. And what that means is that piece has been crowned, and we now call it a king piece. So as a king, you are now able to move in both forward and backward directions diagonally. So to show you this, I'll go ahead and move this guy. If I try to move backwards, you'll notice that it does not work. So I have to move forwards. But this king piece here can now move backwards. So I will move here. And I'll move this guy again just to show you. Now this fire piece has a choice of any of these directions. So I'll show you that I can also move forward once again. And those are the two special rules of checkers: multi-capturing and crowning. Now I want to walk you guys through a quick example that combines all of the knowledge we've gained about checkers so far, and also shows how you can combine the abilities of multi-capturing and crowning to set up some cool combos. So I'm going to start off as fire, and I will go ahead and capture this water piece by jumping here. And I'll be making a big sacrifice because both of my pieces here will be knocked out, but this is a demonstration, so as far as I'm concerned, it's a perfectly reasonable move. Notice that the shield was not wiped out by the bomb's explosion, so now it is water's turn, and I am going to use this shield to capture this fire piece. And now that I've reached the bottom row, you'll notice that I have the crown over my head, which means I am now able to move backwards. And lucky me, there's a fire piece here that I would be able to capture. And actually, I am able to multi-capture in order to grab this piece by going backwards. So I will jump here to show that I can set up a multi-capture where I can crown myself and then be able to move backwards for the second portion of the capture. And I will end my turn. And now that Water is the only team with a piece on the board, Water is the winner of this game. So thank you guys for watching. I hope it was helpful in getting you familiar with Checkers61BL, and I hope you're now ready to start the project. If you have any questions, you can post them on Piazza, you can email me, you can comment on this YouTube video below. And with that said,